All right. Morning, everybody. Well, yep. Let me go ahead and start my watch here. Start the timer so I can stay on track. Well, let's give this a try. This is the first of the video lessons that we I will be presenting to you. We had talked about this. I'd asked you. I'd taken a poll of the class to see how many of you would be interested in doing this, and we had more than a majority. We had about 75% of you guys choosing to do it this ways instead of going live. And so let's try this. The idea here then is that if you have any questions, you guys, please make sure you stick around after I take roll and ask your questions. So that gives me an opportunity to provide you with more one-on-one help if you need it. So my hope then is that after you watch this video, okay, that tomorrow you'll stick around after I take roll, and then you ask your questions about today's lesson. So please make sure you get that done. I think it frees up time for us it frees up time for me to address your questions directly. So I'm not going to make anyone stay behind in order to get your questions answered, but please make use of it. Take advantage of the opportunity now that we have to stick around for class and ask your questions. Now, understand also that I will still be available during class time. So that means, for example, as you're watching this video here, if you have a question about what I go over in this lesson, pause the video and then go back to the Zoom, go back into the Zoom session, and ask me a question about the video. So I think doing it this way will work. It has worked for my other classes, but it really requires that you take the initiative, and if you have a question, um, ask it. Okay, and so please, don't hesitate. Okay, so you still have the opportunity to come by and ask to stick around on Wednesdays after the exam to get your questions answered. You also have the opportunity to come by after my seventh period class at 1:35 to get your questions answered. Okay, and now you have the opportunity during class time to get your questions answered. So please watch the videos, and so you will be required to watch these videos and turn it in. And I will explain that again to you in class, and I'll remind you of that. And yes, I do give you till 11:59 tonight to watch the video. It provides some flexibility as well, and that's why I think this method works here. It provides some flexibility as well for you, but you are required to watch this video before 11:59 tonight and turn in any work, if there's any work, turn in any work into Google Classroom in order to get credit for today's video, in order to get credit for watching today's video. So please make sure you watch the video during class time. And are you required? No, you have to 11:59. But the sooner you get it done, the better it will be. And again, the advantage of watching it during class time is that you can, if you have any questions about the video, you can come right back into class, right back into the Zoom session, and get your questions answered. Okay, so we're going to try this new method here. I think it'll work. It's worked for my other classes, my chemistry classes. Um, so please, take advantage of the opportunity to get that extra one-on-one help if you need it. Okay. Um, what was the other? Oh, and so yeah, don't wait till the end to watch it. I'm not the most exciting lecturer to watch, and so if you put it off until nighttime, I will put you to sleep. So don't do that. Okay, please make sure you watch it during the day, and that way then you can get it out of the way. And if you have any questions, you'll have the opportunity, you have the time then to come get your questions answered as well. Okay. All right. So with that said, let's go ahead and let's pick up where we left off with the discussion on Tuesday. So we started talking about projectile motion. Now let me kind of put this into context of what we've done so far. Okay, so we finished up with chapter 5. We finished talking about forces, and we learned about forces back in chapter 4. We applied what we learned in chapter 4 to discussing forces now in a two-dimensional aspect. Okay? So we went from discussing forces and how forces act in a one-dimensional world to how forces act in a two-dimensional world. Okay. Now, obviously, we don't live in a two-dimensional world, but for the most part, since we walk on a single plane, we walk on the surface of the Earth. We don't really take into that third dimension quite yet. Okay? But because of that, we move in two dimensions at any moment in time. We can only move in two dimensions at a time. You can't move in three dimensions all at once. Okay? So with that said, then I'm sorry, you could. I'm sorry, you could do that, but for a given set of time for a very restricted amount of time, most objects move in two dimensions at a time. Okay, so that's why talking about two-dimensional motion really does work for us. Okay? And so moving back even further in chapter 3, we talked about one-dimensional motion and describing one-dimensional motion without talking about forces, and that was what kinematics was all about. So bringing it all the way back to what we were doing here in chapter 6, to finish up our discussion of two-dimensional motion, what we're going to do then is we're going to talk about projectile motion, and we're going to focus in on describing motion, which is kinematics, now in two dimensions, describing motion in two dimensions. And so with that said, then what we need to make sure we remember then is we need to remember all those kinematic formulas, which I will bring back and we will examine them. But we need to make sure that we remember those kinematic equations, and we need to learn how to use them. Now we need to learn how to use them and apply them in a two-dimensional way. Okay. And so with that said, then let me go ahead and share this screen with you. Let me go ahead and open up screen here, and let's take a look at what projectile motion is. Okay. All right. So with projectile motion, again, like I said, over a given window of time, okay, a very small window of time, we see then that objects tend to move in two dimensions. Okay? And so here what we have then is that when we talk about projectile motion, okay, we will have objects moving in the upward and downward direction. Okay, so make sure you keep that in mind. So you're going to be up and down. Okay, and please look back. I posted the notes for you for the lesson on Tuesday, and I talked about the different planes that we will be dealing with here. All right, so what we will be talking about here, the motion we will be dealing with here, okay, involves an object moving along an upward and so vertical and horizontal plane. Okay, so I'm going to go ahead and draw this in here really quickly. So when we focus in on this, okay, we will be dealing with an object that moves forward and backwards. Okay, so along the x-axis here, it's going to be forward and backwards. So positive would be forward. So we will be dealing with an object, okay, moving forward. That's going to be the positive direction, or backward. And that's going to be in the negative direction along the x-axis, and also up and down. So drawing our coordinate axis here, we will be having an object that's moving up or down, okay, and forward and backward at the same time. Okay, and so up then would be positive on the positive y-axis, and down will be on the negative y-axis. Okay, and so when we talk about projectile motion, we're talking about an object that does both of these. Either it's moving down and forward, we can talk about down and backwards, but here, if you notice, most of the problems we're going to be doing will always be an object moving forward. Okay, okay, or it can be moving up and forward, up and backwards. So those are the two-dimensional aspects of this motion that we call projectile motion. Okay, up, down, forward, or backward. Okay, so make sure you keep that in mind as we move forward with this. Okay, all right. So with that said, then what we have to be able to do when we talk about projectile motion, we need to be able to describe motion. Okay? And the way we describe motion, remember, is in terms of displacement. So we have to be able to describe the displacement, okay, in the forward and backwards, upward and downward direction. So we have to deal with displacement, and we have to deal with displacement in the upward and downward and the forward and backward direction at the same time. And how do we indicate that? We indicate that by delta x. Delta x then, it will be then the displacement in the forward and backward direction along the x-axis. Okay? And also delta y, which is going to be then the displacement in the upward and downward direction, okay, along the y-axis. So we have in two ways we have to consider displacement in the x and the y direction. Same thing will then be true then for velocity. Okay, so velocity, when we deal with projectile motion, Velocity has to be dealt with in the forward and backward direction, and also in the upward and downward direction. So again, what do? We use the velocity along the x-axis. Okay, so v sub x then will always deal with velocities along the forward and backward direction. That's along the x-axis. Okay? And velocity along the y-axis. Okay, that means an upward and downward as well. So the issue that I think many folks have had in the past, okay, and I suspect some of you will have also when we deal with projectile motion, is that you have to keep track of this. You got to be able to keep track of displacement both in both directions, for and along the x. So I'm going to the forward and backward direction from now on, I'll be referring to as motion along the x-axis instead of saying forward and backward every single time. And motion along the y-axis instead of saying up and down, okay, which is a little bit easier for me to say, so I will refer to that. Okay, but more often when instead of saying up and down, I'll say then motion along the y-axis. Okay, so we have to be able to talk about displacement along the x-axis and displacement along the y-axis, because again, in projectile motion, an object does both move along the x and along the y. Okay? And so with that said, then we will have acceleration. And in the same way, we will discuss acceleration along the x and along the y. Okay, so we will have to refer to acceleration. Okay, and when we refer to acceleration, we have to talk about acceleration along the x-axis and acceleration along the y-axis. Okay, that is the object accelerates. Now remember, if the object has constant acceleration or a constant velocity, then it doesn't accelerate. Okay? But the point that I'm trying to make here to you then is, before we continue dissecting this this problem here, is that you got to make sure you keep track of motion as an object moves in this projectile manner, in this parabolic manner here. Okay? That you got to be able to keep track of the motion in two directions. Okay? Along the horizontal, along the x-axis, and along the vertical, okay, along the y-axis. Okay, so you got to make sure you keep that in mind as we move through this. Okay. All right, and again, like I said, we will be applying the kinematic equations also in this manner here. We will be applying kinematic equations, okay, along the x and along the y as well. Okay. Now, certain things that we have to make sure we assume as we go through this, and I want to keep talking just as a quick review here. Okay, some assumptions that we have to make when we talk about projectile motion. Okay, so some assumptions that we have to make when we talk about projectile motion, and we need to, because it makes it a little bit simpler for us to do this. Okay, first thing we have to do is consider that there are no forces but gravity. And let me go ahead and rewrite this. So there are no forces acting on the object. Okay, no forces but gravity. Okay, no forces but gravity acting on this object. It means no air friction, no objects pushing or pulling against the object as it moves. Okay, so there are no forces but friction acting on this object. Okay, and then we'll talk about that as well. Okay, a couple of other assumptions that we want to make here then, that we ignore the rotation and curvature of the Earth. Okay. Again, this is something I pointed out to you. For many of us, if we don't go beyond this first year physics class, okay, that's not going to be an issue for us. But for a few of you, okay, you're going to move on either into engineering or aerospace engineering, or hopefully into launching rockets or whatever. Okay, and so at that point, then you cannot afford to ignore both of these factors. But on the most basic level here, we're going to ignore those as well. Okay. All right. Finally, then, that the motion that is plotted out by projectile motion, then is going to be parabolic. The motion is parabolic, which means then it has this curvature to it. Okay. And so the reason why it has that curvature we're going to talk about, but that's what you want to make sure you remember. Okay, so those are some of the assumptions that we're going to make as we move through this. Okay? All right. And so what I started doing for you, okay, and I'm going to pick up with what we left off with on Tuesday, is that I've drawn for you a an object here. So the object is in black. It's our black circle. Okay. And what we've done is we're following the object's motion through time. So at the very beginning here, it's going to be time is going to be equal to 0. And so let's go ahead and make sure you keep that in mind. So at the very beginning here, t is equal to 0 seconds. That means it just starts to leave. The way that you want to imagine this is in order to say then that there's no forces acting on the object but gravity. Okay, you want to imagine, let's say this is a ball. Okay, this is a ball and you're throwing it. Okay, you're throwing it out and away from you. So it's going to the ball is going to follow this this parabolic pathway. Any object moving in this manner here will have a parabolic pathway. Okay, that's why we say that, and that assumption works very well. Okay, and so you take the ball and you throw it out and away from you. Okay, what you're going to notice then is that ball is going to follow in this curved manner here. Okay, however, some folks have asked in the past, well, wait a second, if there are no forces acting on this ball here, for example, how does it even move? Okay, again, what we're saying here then, remember, we were studying and we were describing the motion. So this is kinematics applied to a two-dimensional world. And remember, when we talked about kinematics back in chapter 3, we were talking about describing motion while ignoring what causes that motion, the forces. Okay, we didn't learn about forces until chapter 4 and chapter 5. And so the same thing holds true here. We're imagining that this ball is just going to make that take this pathway and it's going to move. We're basically ignoring why it even starts to move. Okay? Now, if you are curious about this, if it does bother you, just imagine them as you take the ball and you throw it, it's at some point has to leave your hand. Okay, so yes, initially you are applying a force to the ball to throw it up and away from you, but after it leaves your hand, you're no longer touching it. Okay? You are no longer applying a force. You applied the force, you let it go, and now it's moving. It's moving on its own. Okay, there is no other force that's causing it to move. Okay? There's no other push or pull that's causing it to move. We're tracing the motion here after it leaves your hand. And that's why we can go ahead and assume then that there are no other forces acting on the object but gravity. Okay, so at time is equal to 0 seconds, the ball is moving on its own, or the object is moving on its own. And maybe that'll help you to remind us that that at t is equal to seconds, at t is equal to 0 seconds, that is when object moves on its own. Okay. And hopefully that can help you remember what that t equal to 0 seconds is going to be. Okay. All right. So what I'm going to do then is I'm just going to arbitrarily assign some times here to help us do this. Okay. So this is going to be then t is equal to 1 second. Here it's going to be t is equal to 3 seconds. So at 3 seconds, the ball then reaches the top. This is going to be t is equal to 4 seconds. And finally, when it comes back down here, this is going to be t is equal to 5 seconds. Again, I'm just going to arbitrarily assign those time intervals there. So that way then I can refer to it. Okay, so very beginning, t is equal to 0 seconds. Each interval here represents a second. Okay? All right, so what we're going to do then is, what we want to do then is we're going to trace the motion here. And what you want to see then, and what we want to focus in on first is that the red arrows here represents the velocity. So we're going to focus in the velocity. But if you understand this, as the object moves here, okay, it also undergoes a displacement, okay, both in the x direction and the y direction, which we will talk about in just a moment. Okay, but it has a velocity here, and we know that because velocity, remember, is defined as displacement over time. Okay, so it has to undergo displacement as well, and we're going to talk about that. Okay, but I don't draw those arrows here for you. Okay, so what we're going to do then, remember, we want to make sure that we break up the motions into the x and the y direction here. Okay. All right. So with that said, what I did then is what we started out with on Tuesday was I started to point out to you then that what we want to do then is we want to first of all focus in on velocity. Okay. And then while we do that, okay, I'm going to go ahead and then explain then some of the other things you have to make sure you pay attention to as we go through this. Okay? All right, so what we have here then is what we refer to as the initial velocity. Let's go ahead and take a look at this first velocity here. Okay, velocity at time 0 is going to be then what we refer to as our initial velocity. If you notice, the initial velocity is a two-dimensional vector. We have then a vector that's moving up and towards the right. Okay, which means then, and I'm just going to go ahead and transplant it over here, just draw it over here really quickly. Okay, so if this is our initial velocity right here, okay, and I'm just going to draw it right here for you. That's our initial velocity. Okay. What you want to make sure you can do then is identify that that is the initial velocity. So let's go ahead and write that in as v sub naught. Okay, so that means then that's the velocity at the very beginning. Again, that's when the object is moving on its own. Okay, the object is moving on its own. It has its own velocity here. Because it's moving up and towards the right, we have the components here. Okay, we can draw then the components of this velocity here. Okay, we have then the x component, which is the horizontal component of the velocity. Okay, and then we also have the y component here, which is straight up. And so there it is. What I've done for you then is we've identified then the x and the y components of the initial velocity, and we will label it such. Okay, so this is the initial velocity along the x-axis, and that's what I've done here for you right there. And this is the vector that's known as the initial velocity along the y-axis, v sub y, and that's what I've done for you right here. Okay, why do I do that? Because folks, what we need to be able to do is we need to identify those. Okay? Okay. Or if we need to, we can use these to get to v initial, but we typically will be given v initial. We need to find these here. Okay. All right. So with that said, then how would we find v initial y and v initial x? How do we find the x and the y components of the initial velocity here? Let's go ahead and recall then that if we know this angle right here, or if we know one of the angles, okay, so let's call that angle theta. Okay, and this is what we refer to as in the launch angle. And this is what we refer to then as the launch angle. Okay, that's initial angle right there. Okay, whoops. Okay, so I'm going to write that in here. This is what we refer to as the launch angle. Okay, so we will know that. Okay, so if we know the launch angle, hopefully you recognize then in order to, why we need that launch angle, because if we have that, then we can go ahead and solve then for v initial. Oops, sorry, v initial along the y. V initial along the y then will be the sine of the launch angle times v initial itself. Okay, so we can go ahead and do that. We can also solve then for the x component, and hopefully you remember this. We did this back in chapter 5. Okay, this will be then the cosine of the launch angle times v initial. Okay, so if we know then the initial velocity, and the initial velocities for these will always be, okay, at an angle for the most part. Okay, and we'll talk about the exception hopefully today. Okay, if not, we'll talk about it tomorrow. Okay, but with that said, then that's how we solve for the initial velocity. And if you notice then, after the initial velocity, every velocity vector, okay, will have then a component to it, x and a y. Okay, and with that said, then the angles will then no longer be the launch angles, but it will be an angle that hopefully you will be given. Okay, and so at each point here, what you'll notice then is that you will be able to draw a right triangle. Okay, for each one of these. Okay, a right triangle. So there is the velocity at time is equal to 1 second. So this is velocity at 1 second. So we will, instead of v naught, this is going to be v1. Okay, and so we can go ahead and draw then the components then for v1. So there will be a right triangle here and a right triangle here. Okay, and the angle here is no longer the launch angle, but it's going to be the angle at time 1 second. Okay, all right, and we can go ahead and solve then for v1 y and v1 x in the same way using these trig functions here. Okay, all right. Now, if you notice then, once we get up, so time is equal to 3 seconds, what has happened here? Okay. Now what has happened is that the object now is moving only along the horizontal. It only has a velocity along the horizontal. Okay. And so that means then at this time is equal to v is equal to 3 seconds here, or we have then the y component here is going to be 0. Okay, so at t is equal to 3 seconds, we have then no y component. It's only moving forward. It's only moving forward. And so the y component is no longer moving up. Okay, the y component then is going to be 0. We will then have to find then what the x component is. So there will only be an x component at this time here. This is the height, and I refer to this point here as the height of the path. Okay, so this is at the very top, at the zenith. Okay, at the height of the path here. Okay, there's some there are some special conditions that we will need to talk about. The first of which then is that the v at the height here, the y component, is going to be 0 meters per second. That is always going to be true. Okay, so that's going to be one characteristic that we will talk about, that we can describe when the object reaches the height of that parabolic pathway. When it gets to the very top, okay, its velocity along the y is 0. Okay, and that will always be true for any object moving in that parabolic, in that projectile manner. Okay, all right. We'll get back to this in just a moment, but let's continue to press onward here, and let's take a look at what happens here. Then the object starts to turn downward. It starts to move in the downward direction. So now it's still moving forward, but it's moving forward and down instead of forward and up. Okay, so here we have then, and let me draw this. Okay, so there is the vector. Okay, that represents then the time, the vector at v is equal to 4 seconds here. So we'll call that v4. And if you notice then, we can still draw the x and the y components for this here. Okay? The x component then will still be towards the right. Okay? The x component is towards the right. But this time, the y component, instead of being up, is going to start moving, is going to be in the downward direction. Okay? Why is that going to be important? Because then with vy here, okay, so this is going to be v4 on the x direction. Okay. Now this is going to be v4 in the y direction. All the y velocities here were positive. This y then now becomes negative. And you got to make sure you keep that in mind as well. Okay. All right. And so again, what we can do then is we can either use, we can find it using this angle right here. If we know that, that'll be theta at 4 seconds. Okay. And we can use that and the trig functions in order to find the x and the y components of velocity at time 4. Okay. And then finally, then let's go ahead and let me just draw this right triangle down here. Okay. We have, this is going to be v final, so we're going to list that as v final. Okay. And let's go ahead and draw that here. So there's v final. And we will label this v final because this is the velocity at the very end of the pathway. So this is going to be v final. Whoops, sorry, let me write it again up on top a little bit here. Pushed at the bottom. So this is going to be v final, okay, and my label here is a little bit off, but on the chart here, but I forgot to put the v final here. Okay, all right. So that's going to be v final. Okay, and if you notice, then v final also has and v final, and this is what I want to make sure you understand. V final is the velocity. Okay, this is the velocity just before touching the ground, just before the object touched the ground. Because yes, and again, this is a point of confusion for students in the past. Everyone in the past, or not everyone, I'm sorry, there quite a few students in the past would ask them, wait a second, isn't v final always going to be 0 because the object stops when it hits the ground? And I would say absolutely, yes. Okay, but when we talk about v final here, this is the velocity right before it hits the ground, and while it's still moving, not when it stops. Okay, so before it hits the ground, and furthermore, when it hits the ground now is exerting a force in the upward direction, which means then we no longer are moving in this projectile manner. Remember, projectile motion. Then one of the assumptions is that the only force acting on it is gravity. When the object hits the ground, there's a normal force now pushing up on it. Okay, and so when we talk about v final, we are dealing with the velocity as it still moves, but right before it hits the ground. Okay, right. So that's going to be v final there. And so with v final, then we can go ahead and we can trace then also the x and the y components of v final and draw the right triangle that deals with that. So there's going to be our x component for v final. And we will also have a y component for v final in that direction. Okay. And again, if we know this angle right here, whoops, sorry, if we are able to obtain this angle right here, which we can, and we'll talk about how we get that later. Okay, we should be able to find then v final in the x direction here and v final in the y direction there. Okay. All right, so this is a really busy screen here, but it provides you with all the information you need to understand how we can calculate for these velocities. Because when we work through these problems here and we do the kinematics, we have to be able to start. And I always suggest that you start by working with the velocity, calculating and determining the velocities first, and then go on to the other ones afterwards. Okay? So that's my suggestion. Will you always go in that order? No, no. But most of the time, if you solve for the velocities first, getting the other pieces of information becomes pretty straightforward. Okay. All right. Now, with that said, let's continue on. Okay. Now, if the only force acting on gravity, only force acting on the object here as it moves is gravity, gravity is always going to be in the downward direction. Okay, so this is going to be gravitational acceleration here, which indicates then gravity. Okay, gravity is always going to be in the downward direction. It's going to be acceleration is going to be -9.8 meters per second squared. Okay? And so therefore, the only force acting on this object the whole time that it's moving is the downward pull, okay, of gravity. So this is the gravitational pull, that purple arrow right there. That's the gravitational pull. So the only force acting on this object is going to be in the downward direction. So therefore, the only acceleration that this object will experience is going to be due to gravitational acceleration, which is along the y-axis, along the downward direction. So this is always going to be along the y-axis, which means then that the acceleration along the x-axis will always be 0. If you notice, if you look at the arrows here, okay, which represents then the x direction. Okay, so the arrows along the x direction. Let me go and highlight that for you here. If you look at the arrows, okay, the x component of the initial velocity, the x component of the velocity at 1 second, the x component of the velocity at the very height, the x component of the velocity at 4 seconds, and the x component of velocity at 5 seconds, they are all the same length. Velocity is constant at along the x-axis. Okay, and so let's go ahead and let's write that down. Okay, if you'll notice here, okay, and let's go ahead, and this is not an assumption, but let's go ahead and write this down. Okay, okay. Some characteristics. So let's go ahead and identify this. There's some key characteristics of projectile motion. I'm sorry. Let me go ahead and put that in there. Let me go just write down characteristics of projectile motion. Okay, the first one being then, there is velocity along the x, not that it's 0, velocity along the x will always be constant. Okay, velocity along the x direction will always be constant, which means then that the acceleration along the x will be 0 meters per second squared. So that takes care of this already. We have no acceleration. The object does not accelerate along the horizontal. So there's no acceleration. And understand, please, please do not forget this. 0 acceleration does not mean that the object is not moving. 0 acceleration means then that the object is not speeding up nor slowing down. And you're going to ask them, wait a second, if you throw the object and it's moving horizontally, wouldn't friction slow it down? But remember, there's no forces acting on except for gravity. So that means that we are ignoring friction. That's why then the acceleration is 0. That's why there is no force acting on it along the x. Okay? So there's no force acting along acting on the object along the x direction, because again, the only force acting on the object is the force of gravity, which is pulling it down. Okay, all right, which means that the velocity along the y is not constant. And we can see that. Look at the arrows. Look at the arrows along the y. You have it very long. V initial, it's longer than v the velocity at the time 1. Okay, and again, we're looking at the vertical arrows now. Okay, and then it's gone. It disappears completely. So the arrow is getting shorter, and then it stops there. That means the velocity is decreasing as it goes up. And then what happens as it starts to go back down? Look what happens to the length of the arrow along the y. It gets longer and longer. Okay, so velocity is decreasing as you go up and increasing as you go down. So the velocity is changing, so it's not constant, which means then you have an acceleration along the y. And what is that acceleration along the y? It is gravitational. acceleration. Okay, so acceleration along the y then is going to be acceleration due to gravity, which is this 9.8 meters per second squared. So that's negative 9.8. So this is the only acceleration here. Okay? All right. So make sure you keep that in mind as we go through this, because a lot of folks will forget this. Okay? All right. So at the very top here, I'm sorry. I'm running out of time. Oh, yikes. All right. So let me go ahead and just finish up here, and then we'll continue talking about this tomorrow. Okay. And that means that when you, as the object is moving up, okay, if you notice here, the velocities are all positive. They're on the positive side. Even over here, the velocity, the velocities are positive. They're pointing up. Okay, so that means that as the object is moving in the upward direction, okay, as the object is moving in the upward direction, okay, what do we notice here? The velocity in the upward direction, in the upward, as it's moving upward, okay, velocity is positive. Okay. Acceleration is always going to be negative. G is always going to be negative. So what does that mean? The object is slowing down as it goes up, which makes sense. Throw an object up in the air. What do you notice? It moves up, up, up. Then it starts to slow down, and then it eventually stops at the top right here. It stops its upward motion. Okay, and so that when it starts to move back down, so in the downward motion, if you look at this on the way down, the velocity now is negative. It's pointing in the negative direction. The acceleration is also negative. G is negative. So therefore, what's happening when the object is moving back down? It is speeding up. So it is changing. It's speeding up as it goes down, and it's slowing down as it goes up. Hopefully that'll help you. But that is what you need to make sure you keep in mind as we continue to go through this. Okay, okay, so on tomorrow, in tomorrow's lesson, then I'm going to finish going over this. And again, I know that this is fairly busy. I'm going to go ahead and save this for you, and please take a look at it. It's full of information that can help you. Okay, so I would suggest that you take this slide here, okay, and print it up, print it, and have it in front of you as we work through some of the problems. And hopefully we can start it tomorrow. Okay, as we work through some of the problems tomorrow. But I'm going to finish filling in this table tomorrow. I'll finish filling in this chart tomorrow, this diagram tomorrow, and that'll help you with the solving. Okay, so just a few last things we'll talk about. We'll talk about what happens at the height, okay, and then what happens with when we have symmetrical motion. Okay. All right, so for today's lesson, then there's nothing that you have to turn in. I basically just talked and went over the characteristics of projectile motion with you. But starting tomorrow, hopefully we'll be able to work through some problems, and that way then you'll instead of the problem that you used to work out for me on a whiteboard, you'll work out on a separate sheet of paper, and then you'll turn it into me at that after you watch the lesson. Okay, so so nothing to turn in today, but hopefully tomorrow you'll have something to turn in. Okay, all right. So again, please make sure you come by and make sure you get your questions answered. About this was a lot, folks. This is pretty dense. This is a lot, very informative. We went through quite a bit in here, so please make sure you stop by tomorrow after I take roll before I dismiss you. Please stop by tomorrow and ask for clarification if there's something here that didn't make too much sense to you. Okay, take advantage of the opportunity to ask me the questions. Okay, on a one-on-one basis now, so you don't have to worry about other people wondering what you're asking. Okay, so please make sure you take advantage of it. This is the reason why we're doing this now. Okay. All right, so hopefully I'll see some of you. If not, then I will see you folks on Tuesday. I'll see you folks on Tuesday, and then I'll dismiss you to watch Tuesday's lesson. Okay. All right, very good, folks. Have a good rest of your day, and I will see you tomorrow morning on Tuesday. Okay.